here now. Let me see. I hope my sound is fine. Yeah, let me just test my sound. I think every day I'm going through this. I test the sound in the beginning. Okay, yes, the sound is fine. So today I want to start with doing the ray tracing in one weekend. I think I saw it during the summer. It's been a while, and I always wanted to do it, but I haven't found the right weekend for it yet. So yeah, and this is a good weekend, I think. I don't really have an idea of what ray tracing is. I knew it's some kind of technology that's supposed to make your game's FPS go down, but besides that, I'm pretty much, yeah, I don't know. I'm not going to read aloud, but I will read this kind of very fast and maybe like say something about it. Yeah. So it says when somebody says ray tracing, it could be many things. What I'm going to describe is technically a path tracer, and a fairly general one. Yeah. Well, it's good that we're using C++ because I think C++ is relatively, well, at least for me, it's relatively like easier and one of the clearer languages, I think. Okay. We're just going to do the regular one for now. I tried this first example beforehand, and that's actually what I got stuck yesterday, because yesterday I think the output was just like way off. I wasn't sure what's happening to the to my image file, or I don't know what part is wrong actually. So, but now I fixed it. So it's basically, yeah, ppm. Oh yeah, this is using the ppm format, which I was not familiar with. I just googled a ppm viewer. It's in the other tab. I'm going to show it later. But basically, I don't think most of the things that you have on your Windows can show a ppm file. So that's that was also where I got a little bit stuck yesterday, because none of the none of the image viewer can show a ppm file, so I had no way to really test which part was wrong. Besides using a notepad, I was just using a notepad, but changing the numbers and then plug it into different image viewer was just too much work, and yeah. Well, yeah, that's why we didn't do this yesterday. But now let's make some C++ code to output such a thing. I basically copy and paste the C++ code. So we have the integer image width and image height. Both of them is 256. It's going to be a square. And yeah, this is just a line telling you the size of the image. So this double for loops. First one, image height -1, from 255 all the way down to 0. And this one going from 0 all the way to 255. It has three variables, RGB. I was not, well, I mean, it's red, green, and blue, but I actually don't know what the significance here is. My guess is that this is going to do a gradient. B is staying at 0.25, but R and G are both going to do a gradient that kind of goes all the way from 0 to 1. Well, I mean, it's dividing by 255, so the double I is going from 0 to 255, and the J is going down from 255 to 0. So both of the R and G are doing a gradient. I think this is just a way to just cast the double or the float to int, so that well, it has I feel like it's like the I don't want to say pixel, because maybe pixel is not the right measurement there, but well, it's some kind of conversion that makes the format match. Okay, so I can build and run it again. but I actually already built it and run it. So yeah, build succeeded, and let's do the command line. I was also I apparently had like multiple parts that I was trying to figure out yesterday, but well, now this one is built, and you can see here in the in the output folder there's a output file for image ppm. Like you can see, all of this is standard out, but we don't want standard out. Like standard out cannot show us what our picture looks like, so we output it into a ppm file. Okay, let's do it. Let's wait. I probably need to cd into that folder. Yeah. Let's just get cd into that folder and ray tracing. We want to output the file into the ppm so that we can view it. Wait, what is this? Did I not build it? Oh, okay, it's ray tracing 1. Okay, so now we have it. ppm viewer. Well, it's probably the same file. It's going to see. We're going to see the same thing. And yes, this is the image ppm. As we can see, it is a gradient. I was not sure about like how the gradient would change. Let me just try something. Let me switch. Well, let's try switching G and B. Like if G were staying 0.25 and B were staying, and B became the gradient from 255 to all the way to 0. Let's see what's going on. Yeah, just to make sure that we kind of understand what's going on. And okay, let's reload the image. I hope the image still works. No, not really. Let me try again. Oh, it's actually the same. Okay. That was surprising because I thought keeping B constant was the way to make the gradient like facing a certain way. Like you can see the green and red are but actually it doesn't matter. So okay, I guess I didn't really understand it. Let's continue reading. Okay, the pixels. Yes, so it was the pixels. Pixels were the right way to measure it. And the rows are written out from top to bottom. Oh, okay, so RGB doesn't... Oh, okay. RGB kind of confused me a bit. I thought there's something going on with the real, like, color thing, but it's... yeah. Let's continue. Each of the red, green, blue components range from 0 to 1. Okay, yes. Well, I feel like this is really... okay. I really misunderstood it in various ways already, so yeah, let's continue. We eternally use high dynamic range, but before output we were told map to 0 to 1 range, so this code won't change. Let me fix the code actually, because we changed something. We changed something, and I feel like if the data code want to continue using this, we'd better make it. Okay, made it original. This is the original version. Red goes from fully off to fully on, bright right, from left to right, and green goes from black at the bottom to red. Yes, that's the thing. I feel I was not sure why if we switch blue and red, the color doesn't kind of switches the way that it do the gradient, but let's continue. Yeah, we already did this. And yes, we can also see the real file of image ppm. Yeah, the first time it actually printed to my command line, so it was a super long list of. You can see this. The first column is increasing from 0 to 255. And yeah, it's basically. I don't want to say a very Oh, it's not that kind of matrix, so yeah, let's continue. Adding a progress indicator. We could add a progress indicator to our outputs. This is a way to track the progress of a long render, and also to possibly identify the run stalled or due to an infinite loop or other problem. Okay, so we are going to write this. Basically scan lines remaining. Okay. And in the end, if it's down, then we output down. Nope. Wait. That's why I don't like this keyboard. Like every time I try to slash, it has some kind of risk of just going off. And I have to actually look at what I'm typing, which is very new to me. It's been a really long time since I'm like looking at the keyboard. Okay, so this is a line that kind of catch the intermediate steps and tell you what's going on. And the last line is, oh yeah, I keep hitting enter thinking that was the way to do the slash. Yep. Okay, so this is the main render that kind of have the progress reporting. For now, I don't think we need it, and I assume this would compile. I don't think it can cause any problem, so I'll just, yeah, if you succeeded. I'll just continue reading. Almost all graphic programs have some classes for storing geometric vectors and colors. In many systems, these vectors are 4D, 3D plus a homogeneous coordinate for geometry, and RGB plus an alpha transparency channel for colors. Okay, I understand RGB plus an alpha channel, but I don't understand what the homogeneous coordinate for geometry is here. For our purposes, 3 coordinates suffices. I think so. Yeah, I agree. We'll use the same class vex3 for colors, locations, directions, offsets, whatever. Okay. Well, I think for now we can learn the vex3 first, because I mean I don't even know how that's going to apply to our code yet. So, yeah. Okay, so we need to have a new class called vex3. This is, should I just scan through? Oh, okay, vex3. Vex3 H. Okay. Let's make that. Okay, so this is our vex3h, and for some reason I'm not going to type the whole thing. I just I think I'll type something to make sure that as I'm like saying things, I really understand it, not just reading them. So class vex3, public method, vex3. Okay, if I have so many typos, maybe I'll not type a lot of things then. But yeah. Okay, so this is the default constructor, and this is the constructor that takes 3 double values. And yeah, everything here is very understandable, I would say. So one, two, okay. What's next? Double, yes, return. Okay, I'm just going to copy and paste this part because it's just very repetitive work if I were to just type them myself. And I'm going to type the next part. Vec3 operator. Okay. Return vec3. This is kind of a reflection. I don't know what the reflection is for. Like, is it for the color or for some? I mean, it's generic at this point, so it can be for anything. It's just a way to kind of flip the whole thing. Can be useful, I think. Wait. Yep. Double operator. This is just a get. We are getting one of the 3 coordinates. Okay, and this is okay. More get. Wait, sorry, my keyboard keeps giving me the wrong place. Okay, so that's vec3 operator plus a way to modify it, I think. Oh, is this like you can do something on top of another object that already have a 3D coordinates, like whatever that object is? Yeah, I'm going to copy and paste this part because that's also repetitive in my opinion. Yeah, you're doing some kind of no, not really. Well, I'm not sure how it is really used, so I'm just not going to guess at this point because I don't think I'll guess it right. And this is a multiply. And I'm just going to copy the multiply because you're basically changing plus to multiply. And this is divide, you are getting the inverse. I'm also not going to type this. Length, square root. I don't know what this means. We could try and see what's happening here. Okay, so square root, yeah, we use standard square root, and okay, so that's what makes me a bit confused because I was like, what is the squared? What is the length? Okay, so next is the length. This is length squared, also return constant. Oh, okay, this is a dot product. Okay, I see. I think that totally makes sense now. This is getting the length, so yeah, it's like really getting the length in the way that the length squared is a dot product. So yes, okay. I think it's always good when your linear algebra paid off. Yeah, I really feel happy like every time like linear algebra got cute. So, wait, my keyboard is messing with me again. I'm trying desperately to finding the brackets and plus, and also multiply. E2 multiplied by E2. Okay, so this is literally the length. Public double E3. I'm having like so many typos that I feel like I should just connect my old keyboard to this monitor, but I don't think that's so easy to do. Okay, type aliases for vector3 using point3 equals to vector3 using color. Okay, so these are the different ways that we are trying to use. Okay, That's it. That's it for vector 3. We use double here, but some ray traces uses float. Either one is fine. I mean, for now, I don't see. Yeah, for now, I don't see many differences. I would say so. Let's just do it for now. Do this for now. Yeah. Vector utility functions. Let me see what this is. Vectors. Okay. So vector utility functions. I kind of want to copy and paste it because I know it's going to cost me a lot of time. Yeah, standard O stream, standard. Okay, sadly I don't know a lot of. I know this is doing plus and this is doing minus. This is doing the. Yeah, this is just a multiply, like a regular multiply. And this is a scalar multiplication. Yeah, scalar multiplication. Yes, like kind of an inverse of scalar multiplication, dot product, cross product, and unit vector. Okay, so far this is all linear algebra, I think. Okay. Using the new vec3 class, we create a utility function to write a single pixel color out to the standard output string. So we're doing something called color age. Let's add something called color age. Color age is going to include the vec age and the IO stream. Okay, so let's just do some function declaration. IO stream color pixel color. Okay, write the translated value. Yeah, this is just a way to translate a value between 0 to 1 to something between 0 and 255. And if. Okay. So I think this is what we want for now. And let's include the two files that we just had. Include color and include x3. Okay. What did we change for that? Oh, okay. So we didn't do a very. Okay, I'm going to slash out this part. Slash out. Yeah, we pretty much don't need any of this. So, color is like, for every pixel we use this format. Image width -1 and double J. This is a very similar calculation, I think. We're just changing the sum of the variables to the objects we already declared. Okay. And right color. Say OUT. Okay. That's it. Can we try to build it and see if it can build? Okay, I think it's build succeeded. Scan as remaining down. Okay, so this is down, and let's use our PPM viewer to see what's going on with the picture. The picture is very much the same because we basically use the same format. Well, not the same format, but we use the same same data, like same numbers for every pixel, so it should be the same. Yes. Okay, so this is the final code for our first PPM image. I think we did pretty well. nothing really went wrong, so it's good. Let's continue. We need to learn something now, I think. The ray class. The one thing that all ray tracers have is a ray class and the computation of what color is seen along the ray. Let's think of a ray as a function p of t is equal to a plus t times b. Here p is the 3D position along a line in 3D. A is the real region and b is the ray direction. Okay, it's a linear ray, that makes sense. And the ray parameter t is a real number, double. Plugging a different t and p of t moves the point along the ray. Adding a negative t value and you can go anywhere on the 3D line. For positive t, you get only the part in front of A. And this is what is often called a half line or ray. Oh, okay, so like ray tracing kind of, if it's a ray, then, well, it's not a line, so it's only have one direction and you can go onto the positive direction, but here we also mentioned that we could have the negative direction as well. Okay, the function p of t, we are going to make a function called at double t, and this is the linear function that we just have, the a plus t times b. Okay, so let's make a ray class now. This is ray.h, yes. I don't want to just copy and paste the whole thing, but I also don't want to write things that are super just repetitive and wasting our time. So yes, let's make sure. Yes. Okay, so now we have this default constructor, and let's have the constructor that is more often used, I think. That's given origin and given vex3. Vex3 is the direction, so that makes sense. Okay, and point 3, vec, they are just two get functions. Going to copy and paste that. Okay, and this add function is a p of t function that we are very interested in, I think, or it's just the backbone of why this could work, because it's a linear function that's representing the ray. Okay, and public. Yeah, public is just the point 3 and back. Okay, so we have our ray class now, and sending rays into the scene. Now we're ready to turn the corner and make a ray tracer. At the core, the ray tracer sends rays through pixels and computes the color scene in the direction of those rays. The involved steps are: first we need to calculate the ray from the eye to the pixel, and then we want to determine which objects the ray intersects, and 3, compute the color. When first developing a ray tracer, I always do a simple camera for getting the code up and running. Okay, so we're going to do that first. Oh, okay, we are not going to use a square image now. I mean, our first example was square, but now, since it could cause some problem, let's just switch to 16:9. We also need to set up a visual viewport through which to pass our scene rays. For the standard square pixel spacing, the viewport's aspect ratio should be the same as our rendered image. We just pick a viewpoint 2 units in height. We also set the distance between the projection plane and the projection point to be 1 unit. This is referred to as the focal length. Okay. I'll put the eye or the camera center at 0, 0, 0. So it's this point. The y-axis going up, x-axis to the right, and z is here. Yes. So we are going to traverse the screen from the upper left-hand corner, and use 2 offset vectors along the screen side to move the ray endpoint across the screen. I am not exactly following, so I think we'll have to see what it turns out to be. Below in the code, the color the ray R goes to approximately the pixel centers. I don't know what that means yet, so let's just read the code and then understand as we go. Okay, so ray tracing CPP. Now we need to also include the ray class we just have. What's this? Never mind. Okay, so this is a new class, and we want to make a color object, ray color. That's taking a ray as input, and the vec3 unit direction. So we want to make the unit vector out of the whatever direction the ray have. Wait, that need a couple of parentheses. I hate the parentheses here. Okay. I think T is just reparameterizing the thing, so yeah. But I'm not sure why they reparameterize it this way. Like, why does it take oh, I guess it doesn't matter. Like, you could also use X, so it doesn't matter. Yeah, this is literally like a reparameterizing a line, so I don't know how to explain it. It's really like linear algebra or calculus is just like 1, 1, 1. I'm just not going to type 1.0. But this is the definition of how to reparameterize a line, so yes. Yeah, I always feel really happy when I'm like reaching this part. It's me, the mathematician part of me going on here. Okay, so we are going to change the ratio. That's 400 because we don't want the square anymore. And okay. I'm just going to do 16. I just don't want to type the 0.0 in this keyboard. Is static cast int. Wait. Image with Yeah, like every time I press enter, it doesn't really take the first option. It just like do an enter. I literally don't understand what's going on with my keyboard. But okay, so now it does this, and then we're going to set up the camera. Viewpoint height. I probably I'm just going to copy and paste this part because it's not really a point in typing them. Our viewpoint height is 2, and the viewpoint width is we keep the 16:9 ratio, and the focal length is 1. We just use it as a unit to speed up the computing part, I think. And the origin is defined at 0, horizontal is viewpoint width, which is kind of the ratio, whatever that's calculated to be, and the vertical is at 0, 2, 0. Lower left corner is horizontal, vertical, origin. Oh, okay. Yeah, this is literally the lower left corner of the rectangle that we're having, and yeah. I'm just going to copy and paste this. And the renderer. It's not changing a lot outside of the loop, so it's keeping these 2 lines because they are still using the same way to. Wait, are they still using the same way? No, not really. So I'm going to slash out this line as well. We are keeping the last line, but we are writing all the lines before that. So we have an auto U and an auto V. This is well, the U and the V are basically the same as the RNG here. We are still doing it from 0 to 1. And this is the ray that we are just that we kind of already set up from origin to this direction. And the color is the ray color. I actually don't remember what we have for the ray color. Oh, okay, that's the line that we just parameterized. Okay. I'm very curious about what. Okay, yes, it actually has a nice explanation, far better than mine. I was trying to think of a way to explain how the line goes, but yes, let's read it. So the ray color function linearly blends white and blue depending on the height of the y coordinate after scaling the ray direction to unit length. Because we are looking at y height after normalizing the vector, you'll notice a horizontal gradient to the color in addition to the vertical gradient. I then did a standard graphics trick of scaling that. That's literally the part I was talking about, the linear blend or the lerp. Okay. Sounds very funny. A lerp is always the form. Well, it's basically like any linear parameterization is this form. So yes. In our case, it produces this. It should be very nice. Let's see. I hope it can build. Okay, good. Okay, we're done. And let's see what's going on here. If it still stays the same, I'm going to feel a little bit weird. Yeah. Wait, this actually stays the same. I don't think it's working there. How is it possible for it to? I don't know. I kind of want to delete it and do it again because I feel like it shouldn't. Okay, then now let's do it again. Oh, it's actually still the same. Okay. I feel like I did something wrong here, but that's No, it shouldn't do this. It should render a blue to white gradient. It definitely shouldn't do this. Did we not slash out some part that we were supposed to slash out? Like it is doing that thing, but that thing is not right, I feel like. I don't know. Let's continue reading. I'll try to fix it if there's I think there's something wrong, but I'll fix it later. Okay, so the equation for squared center that origin of radius are okay. This is like linear algebra calculus once again, but let's do it. Yes. Just how to define a square basically. Yes. You can read off the coordinates of the sphere center from this. Yeah. So the dot product is yes. I'm just saying yes because everything makes sense, but I don't know, like to me it is obvious, so maybe it's not really for, I mean, it's definitely not really for most people, but for me it's just like the basic way that how to define a square, how to define a sphere. And yes, this is like bringing me back to my multivariable calculus so much because I never thought that I would meet them again here. Okay, so we are seeing some t that satisfy the square equation, and yes, this should satisfy this. And you just expand the whole thing. Yeah, I'm totally not good at really calculating this thing, but it really makes sense. The unknown is t, and the equation is quadratic, yes. Now you can solve for t, and it's either positive, negative, or 0. Yeah, if it's 0, then it doesn't have a solution. If it's 1, then it only has one intersection. If it's 2, then it has two intersections. That's okay. That's nice. If we take that mass and hard code it into our program, we can test it by coloring red any pixel that hits a small sphere. We place that as -1 on the axis. Okay, so we are going to do a hit sphere. This is all very new function. Let me copy and paste this. So it basically has this point center and this double radius and this ray that we fixed called R. The vector 3 OC is the vector that's from the ray to the center of the sphere, and A is okay. So this is this formula, like how you expand this formula. This is basically what you have if you get all the coefficients, the coefficients for the quadratic function, and you compute the discriminant. Yeah, yes, very familiar formulas now here. And I mean, if the discriminant is 0, then it doesn't intersect the sphere at all. I guess there's no point in returning that. So yeah. And the ray color, if it's hit, then you return color 100. I was really stupid. It's just like while I was doing the build, I didn't realize the build doesn't like automatically ask you if you want to save the thing. So I assume it saved the thing, but actually it didn't. I feel like it never saved the thing. So I'm just going to rebuild the whole thing again. Oh, rebuild failed. Wait. Okay, that's a really not good thing here. Vector 3H. We did something wrong with that, I think. No, vector 3H. The utility function. Yeah, I was really rusty with this part, so I actually wasn't sure what are we doing here. I think that's where we went wrong. Okay, so what else? Are all of them on ray tracing on CPP? Cannot convert. Okay, so now rebuild succeeded. Hopefully we are doing something here. Okay, we did it. And I really hope this time this is not the same image. Okay, it's still the same image. I think there's something very wrong here. Oh, okay, yes, we're getting it. The reload image is not really working. I'm not sure why it shows that is. But anyway, it's fine. We're going to just refresh it and choose file again. Okay, so this is the file we're getting. I think the size is not very nice here because it's not supposed to be a square. Why is it still a square? I thought we already changed the aspect ratio, but or maybe our viewer is our image viewer is not good. So I mean, for now, if we are not having bugs, even if it's a square, it's fine because the that basically says we're doing a rectangle because square can cause a lot of bugs. So now let's continue. Okay, so we get this image and this lacks all sorts of things. Yes, we are lacking all the shading on the sphere, and yeah. But we're closer to halfway down than we are at the start. Yes. One thing to be aware is that we tested whether the ray hits the sphere at all, but T less than 0 solution works fine. If you change your sphere center to z equals to +1, you will get exactly the same picture because you see things behind you. This is not a feature, yeah. I don't think that should work. Okay. Surface normals and multiple objects. Shading with surface normals. I kind of have a feeling that I know what it means, but I want to continue reading. First, let's get ourselves a surface normal so we can shade. This is a vector that's perpendicular to the surface. Like very familiar stuff for me, but yes. To the surface at the point of intersection. These are two design decisions to make for normals. The first one is whether the normals are unit length. I think so. I think they should make them unit length, yes. Okay, they are not enforcing that. Well, I guess it doesn't matter in some cases because this could cause subtle bugs. Okay. Well, I think it never hurts to make a vector like unit, so the outward normal is in the direction of the hit point minus the center. Okay. On the Earth, this implies that the vector from that's basically a definition of a normal. Like otherwise, why would it be a normal vector? So okay. Let's throw that into code now and shade it. We don't have any light or anything yet, so let's just visualize the normals with a color map. A common trick used to visualizing normals, because it's easy, and is to map each component to the interval from 0 to 1. Well, it's a similar thing. That's just as we did the parameterization for the ray. So Yeah, for the normal we need a hit point, not just whether we hit or not. Well, I think it's very easy to get the hit point because you already have the formula representing the sphere. So okay, that's altering. Wow, the image looks very nice now. I hope we can do that. Double hit sphere. Hit sphere is, oh yes, it's this function. So we are adding some parameters. Oh yeah, we are changing it from a boolean to a double because before we are just checking if the determinant. Yeah, that called discriminant, but actually the determinant is larger than 0. We just want to know if it hits the sphere or not. But now we want also to know at which point it hits the sphere. Okay, let's change this. So if it's smaller than 0, then it doesn't hit the sphere. We can kind of ignore it. Yeah, this returns -1. Well, I think I can just type -1. I don't want to type 0.0. So yeah, if it hits the sphere, then you pretty much do you just solve the quadratic equation, and yeah. 2 times a. Okay. So this is the part that if it hits the sphere, you provide one of the solutions. We don't need to change anything about the quadratic equation. Okay, that's fine. And for the ray color, we're going to change the ray color if the ray hits the sphere, I think. Auto T is hit sphere. That's basically what we just changed. 0.3 is, I don't know why the point is 0, 0, -1. Maybe I forgot some of the parts that's already mentioned, but yeah. Oh, okay. The center of the sphere is at that point. Okay, that makes sense. And the radius is 0.5. Okay. And if t is larger than 0, well, basically means like if it hits the sphere, then the vec3n, the normal vector. Oh, it's so long. I don't know how to type this, but I kind of have to now. At t minus. Yeah, this is basically the way you calculate a vector when you're having all the information about the vector. So yes. And we can return the. I just don't want to type the formula at all. Let me copy and paste this. 0.5 times. Why does it? Is it because the diameter of the sphere is 1? I'm kind of feeling that's the way you normalize things, but I'm not very sure about what is going on. Let's continue. I think we'll understand more later because like everything now looks like it's like mathematically very sensible. So and t is already defined, so we alter this part. I don't think anything else is changed. Let's rebuild the thing again. Okay, good. Okay, and the ppm viewer is not that good, so we need to refresh the whole thing and change the. Wow, no, this is definitely not what it should look like. Something is wrong here. Let me see. I think it's probably some typo. This is not what it's supposed to be. Did I mistype some of the mathematical part? I feel like because last picture was fine, and well, I have to do 1.0, I guess. But I really don't think 1.0 is the part that's wrong. And 2.0 is also not the part, I think. 0, 0, -1, 0.5 are Okay, I feel like I should have just copied. Oh, okay, this is a yes, this is a vector 3. If the vector 3 is not coming from the yeah. Okay, do you see what I did? It's really like the normal vector. Like the normal vector has two directions, but I flipped the axis so the vector completely goes to the like opposite direction. That's why if you look at the picture I had, the way that was like so wrong is like I don't know. It's like a reflection of what it should look like. Well, no, let's rebuild that again. Okay, here. We have that, and oh, it didn't change. Then, okay, then we are into some more troubles. Then. I really feel like it shouldn't look the same, but oh, guess what? We still haven't fixed the problem yet. 0, 0, -1 and 0.5. I basically copy and pasted this. I don't think it can be wrong. So, well, apparently it really can't be wrong, but I don't like typing. I don't like typing 0.02. Every integer number that's supposed to be a double. But the way it's wrong, it's just okay. I thought I knew it because the normal vector was not of opposite direction, but Let's do the build again. Well, I think these are like kind of soft bugs. If this were like really hard bugs that it wouldn't compile, I think I'm feeling like really bad. But now it's still very. I don't know. I don't understand why this part is wrong on this 3. Wait. Oh no. The only part we need to change is the hit sphere and adding the new normal vector to the ray color. But somehow this is not right. I do feel like there's something wrong with how the sphere is working, because the sphere, like the red color cannot. Well, it's like the red color can never go out of the sphere, or the red color is only supposed to be a unit sphere. But now it looks like the red color is everywhere else. Let me see. I just don't know where the typo is. If discriminant is smaller than 0, else... Yeah. Oh, okay. The division. Okay. This is like the part I'm always really bad at. When it comes to like real numbers, I never realize the brackets are at the wrong place because I don't read brackets like that. Yeah, I don't read that. I only read that when when I'm missing like a half bracket. No, please. It's very peculiar. It's very peculiar box and also very specific, I would say. Like I don't know how the middle thing already got the correct retracing, but the background doesn't have the right gradient. It's very I don't know. Somehow the bug makes you like feel very funny about it. But okay, so I guess we fixed this part. The ray tracing is fine, but the picture is not. Okay, so the ray color. I really don't think the ray color should have an impact on everything else, but yeah. Let's see. This part is really copy and paste. We cannot go wrong here, I hope. Oh yeah, okay. Basically I cannot read because I cannot even okay. I just didn't delete the old well, I shouldn't delete it. I should just I should stash it out because This is a way that can make the whole thing red. Although it's not fun and we don't want it, it's the last part. Yeah, I'm just really bad at comparing the old code and the new code, and also I think the file is not doing a good job in terms of displaying where are the changes. So yeah, let's do it again. It can never do a refresh, I don't know why. Okay, so now it's right. Okay, it's really impressive that in like 5 lines of changes it can be like so many bugs, but we can continue now. Simplifying the ray sphere intersection code. So let's revisit the ray sphere equation. Yeah, that's the equation we have, and recall that a vector dotted with itself is equal to the square length of that vector. Yes. Notice how the equation for b has a factor of 2 in it. Consider what happens to the quadratic equation if b is equal to 2h. If b is equal to 2h, okay. I kind of want to ask why is b equal to 2h, but oh wait, yes, because b is defined to be equal to 2h. Okay, I see. Yes, that makes sense. It's just the way we define b, but why would we? Is that such an improvement? I feel like it's just a way of refactoring the code, because we are basically replacing the b with like half b, and you're just refactoring the code. Well, I mean, it apparently they feel like they should refactor the code, so let's do it. But for now, I don't see why we need this part, because the determinant is not the form. I don't think the form changed that much, apart from you're factoring out 2. But yeah, I mean they want to do it, so let's just change this part. Maybe it's more readable. I just don't feel like in terms of calculation it's such an improvement. So yeah. So you're replacing this by half b, and you're replacing this by a, because you factor out the 2. But I don't know why you need to factor out the 2. So if we can rebuild this, I think rebuild failed. Okay, that is very classic. Wait, this is really very classic that I don't know which part is. Oh, okay. I delete the line with. Okay. Yes. Well, I guess like seeing this, you could see like how easy it is to like run into bugs for me. Like I really can't read when it comes to this. So yeah. Abstraction for hittable objects. What about several spheres? Well, yeah, this is this is design patterns that you're not supposed to make an array of identical objects just with their position being different. You're supposed to make an abstract class and then just having an array maybe store the position of them, so that you save a lot of space, and you kind of, well, it's like when you're making a game. Like for example, there's a field and there's a forest map, and you have all these very, very similar trees. The trees are basically the same. It's just the way the sun like hit on them are different, so they kind of look a bit different in terms of shading. The point is you should not have a very long list of trees, like trees as objects there. You are supposed to have an abstract class for this one tree, and then you kind of define the different lights on this one object, so that you kind of spawn like a lot of trees, but only the lights are different. Yeah, that's. I think this paragraph is basically talking about this kind of design pattern. Yeah, yeah. It's some very interesting ideas, I would say. Okay, so well, let's continue reading. Yeah, something called calling an object. No, we should not call that an object. It's just the way that's okay. So the author wants to call it hittable, and that makes sense because that's basically all the objects that can be hit in all the different ways, different shades by the by the ray. And yeah, it has a hit function that takes in array. Yeah, that's what that's basically what I was talking about the tree and the saw. Like it's a very like classic design pattern in like gaming, like game development. Okay, so most ray tracers have found it convenient to add a valid interval to for hits from T min to T max. So the hit only counts if the T we're interested in is inside this interval. And for the initial rays, this is positive T. It can help some. Okay. One design question is whether to do things like compute the normal. If we hit something, we might end up hitting something closer as we do our search, and we will only need the normal of the closest thing. Okay, so let's do the abstract class for hittable H first. I think I might just be copy and pasting this because this is just a way. Well, I mean, if we understand why we need this abstract class instead of having an array of this very identical objects or at least very similar objects, then we can. This is just we want to make that abstract class. This is hittable. This is hittable H, and yeah, it has well, this is basically the struct. This is the point P, and this is a normal vector. This double T is a parameter that we have that's maybe we're only interested in between T min and T max. And here's a sphere. Okay, the sphere is okay. We're just pulling a lot of code that was from the main function to the sphere. Plus, we are adding a well, sphere is extending the hittable because it can be a hittable thing. So we want sphere to be to have that part of hittable, to have that struct, to have these three things inside. Well, not inside the sphere, but in the structure of the sphere object. Okay, so let's do that. Is it a sphere H? I think it's a sphere H. Yes, it's a sphere H. So we are making this. I'm going to copy and paste this because this is definitely causing a lot of going back and forth if I were just to type them. And we need to include hittable because a part of it, well, we need the hittable so that it can be extended here. And the sphere hit. Sphere hit is basically it's very similar to the function that we modified here, the hit sphere. We're basically rewriting it so that it now resides inside the sphere object instead of just as a separate function. We're not doing anything to the well, for now I'm not going to slash out this, but I don't think this function is ever going to be used again because we have this this hit function inside of sphere. I'm going to copy and paste because a part of this function is very similar. I think only some parts require some explanation. So yeah, this is a vector from the origin of the they're basically the same thing. We already see like all this here. Like these are all the things that we kind of rewrite. Yeah, the 4 lines we rewrite here, and then we do the discriminant. Now the return type once again like change back to Boolean because now we are we are like only interested in whether it hits the sphere or not. Again, we are not calculating anymore. And as you can see, this part is a new, like the part that we modified. We are not interested in, like, if the ray hits the sphere in 2 points, then the second point, well, the sphere is not transparent though, so we're not interested in the second point anymore. Yeah, and if T is not, well, this root is basically the place that we're interested in, and we're only interested in it if it's within the T min and T max. And this is the normal vector that we have. If we get to this point, then it means the sphere object also stores the normal vector now. So we have what we need, and this function can just return true to say that the ray has hit the sphere. Okay, so I think we have it. I don't think that would make we didn't modify the ray tracing one, so I don't think the image is going to look any different. I'm not going to run it. I'm just going to see that it compiles. Yes, it compiles, so it's fine. Front faces versus back faces. The second design decision for normals is whether they should always point out. Oh, okay. Like, well, I mean, in the sphere case, it's not interesting. But if it's another kind of surface, then I guess it's very useful. Or the two directions can be useful in different ways. Yeah, for now it's in the direction of the center to the intersection point. It always points out. I'm just not sure how the ray could intersect the sphere from the inside. But anyway, let's continue. Well, I think it would make the light look different, but I don't know why the inside is useful for the case of sphere. We need to choose one of these possibilities because yes, that's what I feel like. You can never have like two like both of the options at the same time. So, oh, this is important for objects that are rendered differently on each side, like the text on a two-sided sheet of paper, or for objects that have an inside and an outside, like glass balls. Yes, that makes sense. Okay. If we decide to have the normals always point out, then we need to determine which side the ray is on. We can figure that out by comparing the ray with normal. If the ray and the normal face, no, it just feels so linear algebra. Like, how do you determine that two directions are? Okay, so this is basically dot product of the two vectors. And see if the dot product is positive. Yeah, let me just reply to something. Yeah, I'm having so much fun with linear algebra. Okay, so yeah, this is a pseudocode that if the dot product is larger than 0, then we need to say the ray is inside the sphere. If it's not, then the ray is outside the sphere. Okay. If we decide to have the normals always point against the ray, we won't be able to use the dot product to determine which side of the surface the ray is on. Instead, we would need to store that information. Okay, so we store it in a boolean. Yes. We can set things up so that normals always point outward from the surface, or always point against the incident ray. This decision is determined by whether you want to determine the side of the surface at the time of geometry intersection or at the time of the coloring. In this book, we have more material types than we have geometry types, so we'll go for less work and put the determination at geometry type. This paragraph doesn't make much sense to me because I don't know what it's referring to. Maybe we'll learn more later, but I don't know what this paragraph means, I think. we add the front face boolean to the hit. Oh, okay. So, well, this boolean is basically, well, it's basically this. It's just calculating the dot product and see if the dot product is less than 0, then it's outside. If it's larger than 0, then it's inside. Okay, a lot of linear algebra. I'm having I'm having very much a good time. This is in the hitable edge. So we add the 3 parameters to the hitable edge, and then we add, and then we calculate it for every sphere. I mean, for every sphere, it can be, it can be different, and it's always interesting, I would say. Yeah, we replace this. We make a more interesting normal, or it can be used for many different purposes. Well, by the way, I was doing the fog of love. I was implementing some of the event functions, and it's just, I don't know. I feel like event loop. I read about it a lot, like so much today and yesterday, but it just feels like a giant wrapper. That's what I felt. Like maybe that's not the direction to go in terms of how should I make the event system. Okay, that's a totally different thing. We're not doing that today. But I haven't figured that out yet. I just feel like event loop may not be as useful as I thought. Okay, let's continue. We just changed the hitable and sphere file. And a list of hittable objects. We have a generic object called hittable that the array can intersect with. We now add a class that stores a list of hittables. Yeah, now like a list of spheres, a list of trees, like a whole forest. That's that's a very nice practice in well, game development or just software engineering. Yeah. So this is the hittable list. Oh, okay. For a very simple reason, I'm going to explain it, but I'm not going to type any of this because it's just too long. I don't want to type it. So far, I feel like explaining it is pleasant, or like everything is right. It's like written in a very concise but understandable way. So I like it so far. Okay, so first we need to include hittable because obviously we're using a lot of the functions and the whole struct for this hittable object. We need to include vector. I think it's because, yes, this is basically an array of hittable objects, like an array of trees, like a whole forest. This is object, and standard vector is well, at least to my knowledge, is the best way to do it in C++. So that's why we are using that. And this is a hittable list. If we have a pointer to the hittable to the array, then we can add a new object to it. We can also clear the object. Yeah. This is basically like a this is like doing standard vector in C++ done right. Like this is very good, very good writing, I think. Yeah, not much for me to say. It's just the way you make a vector and you make it flexible so that you are not like returning like too much. Yeah, I would say like returning too much or too little, and you are not causing any memory leaks. This is a good way. And the function hit. The function hit. Oh, is this function is C? Well, this function is returning a boolean true or false that the given array within the time period t min and t max has hit this thing, well, I mean, if it hits anything, then it returns true. Otherwise, it returns false. It goes through every object until it hits anything. Yeah, this is what it does. And I think this function looks a lot more complicated than it really is. Like it is just saying, well, it is just doing the hits for the whole array. So yeah. Some new C++ features. Oh yeah, vector and shared pointer. Okay. I mean, I'm familiar with both of them, so I understood that. But well, I don't think it's very useful if you don't really like program in C++ to understand them. Well, it's basically the way that C++ like does it. I mean, if you're using Java, you can just use a regular array and not using the pointer type or the shared vector. But in C++, basically, if you want to do a vector, well, not do a vector, if you want to do an array of arbitrary types, this is the way to do it. I kind of want to skip over it because this is not relevant to this problem. And like, if you understand it from any other context, then you understand it here. I mean, I understood it like from other contexts, so it totally makes sense. Yeah, common constraints and utility functions. We need some mass constant that we conveniently define in their own header file. For now, we only need infinity, but we also need to throw our own definition of pi in here, which we'll need later. There's no standard portable definition of pi, really? I actually thought there is, but well, anyway, I thought if you use mass, you can. Well, I mean, they included CMass, but they still do the pi again. So I guess they are. Well, at least there's some point in our definition of pi. So okay, so why is this? Oh, okay, it's like RT weekend. I'm like, what is RT weekend? It's ray tracing in one weekend. It's basically what we're doing. So okay. This is just some utility functions, just mass function, nothing to do with any specific picture, I think. Okay, RT weekend H. I'm just going to copy and paste because it's just math, like nothing ray tracing is going on. Okay, yeah, infinity is I never used this before, but I suppose this is the way you do infinity as a double. I think it's just just a way to cast infinity as a double. Like, or you could cast it to float, I think. Double and float are the two options. And well, we're doing everything double, so now infinity and pi are both double. And degrees to radians, yeah, this is just a conversion of like degrees to radians, like literally. Okay. And the new main function, yeah, we need to include all the functions that we just have. So it's still using color hittable sphere 3. It's okay. It's not using VC3 anymore because the hittable and sphere completely like replace that function. And we do not need the hit sphere. This is the part I don't like about this. Like, I mean, the author like writes the code so well, but they never give a clear indication of where you delete things. Like, I don't even. I know where things are like changed or like added, but I never know when they are deleted. So, I think they should improve this. This is a object called word that's hittable. I'm going to copy and paste this because I feel like it's just so easy to type it wrong. And where is? Oh, okay. So why do they kind of redo the T again? But anyway, I'm going to slash out this part because this part is also what I felt they are not used, but it's still interesting. I don't want to just delete them. Wait. Okay, so this is the new hit. New hit object, and if the whole thing is hitted at all, then yeah. And I'm going to redefine T. Oh, it's not really a redefined T, it's just T was not defined previously, so we need to define it. And we add a new object called word. That's like I'm also going to copy and paste this because this is also not interesting. This is just we add something to the word. We add this, yeah. Oh, so they added 2 spheres. Like the larger sphere is just a very large one. That's kind of like the ground, and the small one is what we had. Okay, looks very nice. And the color, pixel color. If they delete some lines from here, and I didn't find it, it's going to cost so many bucks. That's just what I know now. Like I always overlook things that's not highlighted. So yeah, I think this is the. Let's try building it. I'm not sure it will build. Oh, okay. Actually, it's fine. But even the most difficult part is to get the image right. So I guess. Let's see. Oh, the image is actually right. That's good. And we're going very, we're going a lot faster than I thought actually. Although we had some bugs earlier, but like mostly I think I could just read and then immediately understand and explain it, or at least I understand enough. So that's very good. Let's see how many sections are there. There are 15 sections. I think 15 just sides. So if we finish 7 today, it's going to be good. And then I'm going to play some Elden Ring. Well, 7 is a lot, but I like it, so I'll continue. Well, real camera. I don't even know how to pronounce that word, so I'm not going to pronounce that word. It's section 7. When real camera takes a picture, there are usually no jaggies along edges because the edge pixels are a blend of some foreground and some background. We can get the same effect by averaging a bunch of samples inside each pixel. We will not bother with stratification. I don't know what that is. This is controversial. Well, I don't know what that is. Well, for now we're doing it like their way. Some random number utilities. Okay. So we're adding something into the RT-Weekend, the mass file. One thing we need is a random number generator. Okay, we always need a random number generator for every program, so that totally makes sense. You need a function that, yeah. Well, this is basically the way you generate random numbers. I don't think there's another way to do it. Yeah, and this is just totally the way to do it in C++. I don't think it needs more explanation. It's just if you want to do a random number generator, this is what you do. Okay, so let's do the random double, and the random double that's scaled between min and max. Utility functions, okay. C++ didn't traditionally have a standard random number generator. Well, I don't think it's any different. I used the previous one before and it was totally fine. I mean, the next one could also work. We just need to do some seeding though. I feel like this one doesn't do the random seeding, so every time you generate a number, it's going to be the same. But maybe like for testing purposes, it doesn't matter, so let's keep it this way. If we need, we can add a seeding. Like seeding is super easy here, so yeah. We're just going to seed by the time, so yeah, so a very classic practice. Generating pixels with multiple samples. For a given pixel, we have several samples within that pixel and send rays to each of the samples. the colors of these rays are then averaged. Oh, so this is you can actually do that for any given pixel. I'm very surprised because I didn't know the pixel can be like subdivided and blend this way. Now it's a good time to create a camera class to manage our virtual camera and the related task of scene sampling. The following class implements a simple camera using the axis-aligned camera from before. This is the camera class, and let's have a camera class. Well, I'm just copying and pasting a lot of stuff because I feel like explaining them is so much more interesting than like writing them. The point is, if you know why it works, you can always make it work. It's not the typing part that's important. Okay, so the camera, it has the same aspect ratio as our picture, and the viewpoint height is 2. It's a very, I don't know, it's like a very parallel camera, I think. I mean, versus our world, it's a very parallel one. And we get the ray. Yeah, this is basically replacing the ray and all the parameters that we have. To handle the multi-sampled color computation, we'll update the right color function. Rather than adding in a fractional contribution each time we accumulate more lights to the color, just add a full color each iteration and then perform a single divide at the end. Okay, we'll add a handy utility function to the weekend. Clamp. I don't know what clamp is doing. Let me first have it and then we'll try to understand it. Oh, okay. It's just if the X is going over our range, we want to keep it within our range. That's it. And the color H, the multi-sample right color function. What did we have for color H? Oh, okay. So we are like, yeah, we are improving this right color to be a good blending, a blend instead of just having the fixed RGB. Oh, it's not it still has the fixed RGB, but oh, okay. Actually, I don't need to slash out this part because it's still having the RGB conversion at the end. It's just in the beginning we want to do a sampling and averaging. Okay, that totally makes sense. And what is okay? We need another int to represent how many samples we're taking, so that we can take the average in the end. Yes. Main is also changed to include the camera H that we just wrote. Well, if we just wrote it, why not have it now? So yes, let's include it. And we need to change some of the constants. Here we have the samples per pixel. I wonder, is 100 like a lot or little or like in the middle? I actually don't know. But I guess when we see the thing, we would understand. This part is just replaced by the camera object because all the parameters here are already defined. Well, they are basically the same. That's why I say the camera is like parallel to the thing, because it is definitely the same thing. We're just replacing it. We're just like wrapping it in a camera object. Okay, so now we have this camera object, and we are updating the. Okay, we are updating a lot of things. I'm slashing out. I think I'm slashing out most of this. The right color stays because no, the right color doesn't stay either. I'm just going to slash out this whole thing because I think most of it is either it's changed or it's distributed into different objects. So I don't want to confuse people about what objects are we on right now. So yeah, But a lot of this is like similar code. Like the red color just have one more parameter. It's just the way we update the method of red color. We need to have like 100 samples per pixel, so that now we need to add 100 to this. And this is like I don't know. It's like a blender. Like you blend more and more color in like repeatedly. Yeah, and you're doing it. Yeah, you're doing it like 100 times, because this is yeah. And let's see. Like if we can get the picture back, like look better in the edge. Okay, rebuild failed. Samples per pixel. How is sample per pixel unknown thing? I thought sample per pixel is basically what we just constant int samples per pixel. Undeclared identifier. Where it is? Oh, colored H. Okay, colored H is. Oh, misspell. Okay, I see. I was like, how can color H have a sample per pixel problem? But okay, let's go. Yes, it's. I'm not sure if it's easy to see the difference, but the speed is certainly like getting slower. So there's like a lot more to render right now. You can see the speed is like a lot slower. It's like 100 times slower, I would guess, because we kind of run everything like we blend every color 100 times. So let's see. It's also taking a long time to load. I'm not sure if it's. Is it done? I hope it's still working. It's not like this is too large that it's not working anymore. Oh yeah, it's definitely getting larger. Oh please. I think the image is very large that it is like breaking it or making it very difficult to. Let me just see if there's a better one, because that one feels like it's not working anymore. Oh my god, even this one is not working anymore. Can we change it to like 10 instead of? No, I want to redo it. I'm not sure if we have it. I feel like there's something wrong with it. Because it's still like down in the end. It shouldn't be a blank page. Like now, this is a blank page. Yeah, this is a blank page. And it really shouldn't be. Okay, the good news is not the PPM reader's fault, but the bad news is we're probably not getting an image at all, because it's so large. Can we do 10? I'm very worried about the 100, so let's do 10 and see if 10 has a similar problem. Okay, if we do 10. Well, as you can see, the 10 kind of speed up the whole thing like 10 times. So that's. No, it's still not showing anything. Well, then there's something else that's wrong. For example, the camera is not working. The camera is not working makes it like there's technically like no light going into the thing. I think that might be the reason why it's just blank. I just wonder where did I make the typo, because the typo is so difficult to find here. So 400, you cast the ratio and let's do 100, since I feel like the number is not a problem. The word is the same. The camera is just a cam object, and color, pixel color is. I really copy and pasted this part, so it cannot be wrong. So yeah, this part is that. And what about the color H? Color H has the RGB and has a scale, has a. Oh, okay. This is doing 256. I get it, because we changed the. I don't know. It's like I don't like the way they write this. It's just so difficult to figure out where it goes like different, and like everything went wrong. So let's do it again. If we have we had 255.999, and now everything is like not rounded correctly. That was why last time it didn't work. Okay, the rendering is still slow, but maybe this time it will work. I should have tried 10 so that we can see how it jumped from like 1 to 10 and then the quality jump from 10 to 100. I guess that would be a bit more obvious. Now let's do it. The sphere definitely shouldn't look like this. Or is it because I think it's not that problem. Is maybe because the whole frame is not 16 to 9. Like, can we? Oh no. Wait. Why are they always showing the square? It's actually a rectangle. It's not a square at all. But okay. I think well, you can see that it gets a lot smoother. Although I really don't like the way that kind of like defaults into a square. It's because it's like now it's really a big difference. Okay, so I think this is halfway through the ray tracing in one weekend, and well, we'll do the next half tomorrow. I think I enjoy it a lot. Actually, I enjoyed it a lot more than I thought. So, yeah. We'll do it tomorrow, and now it's some Elden Ring. Okay, I'm going to save everything. I think I have everything, so. Wait. Yeah, I'm going to change it to Elden Ring. Oh yeah, and also the music can stop now. Why is that still here? Okay, so wait a bit until that guy found Elden Ring, but I can always change this to Elden Ring, so. Okay, now this is Elden Ring. Yes, okay, I'm going back to being really bad, I guess. It's very difficult to imagine that ray tracing is easier than Elden Ring. I don't know what's happening. But it's definitely... I'm very stuck here. I want to go forward, but I just can't. I'm too bad. That's... The problem is we practically cannot go inside that, because that's going to like poison us. And... Actually, what is this? River well. Missed rings, waypoint rings. Let's try this. I'm not sure if we did visit that. Maybe we didn't. Let's do this. If we have visited that, then it's just having a map is not really helping. I'm still trying very hard to like find things to do that are not too difficult. But let's go. Yeah, we are at the right direction. Wait, sorry, the sound is really low for me. I don't even hear the enemies. Yes. Oh, wait. Am I in the wrong direction? This is the direction I'm going? Yeah, this is the direction I'm going. Okay, I just need to run away from that guy. Depending on how easy it is to run away from that guy. Oh no, I'm in the fight. I cannot see the map. What about now? If that guy goes here, it's going to be really difficult, but okay, it's not going here. Oh, we are jumping this. Okay. Hopefully we are not going to die here. Okay, if we are not dying, that's good. Oh wait, why is there a... Okay. I just kind of jumped right to the bear. And if you go straight, there is a cave. Wait, that cave is... That is... Oh my god, this is actually upstairs, it's not... Okay, I'm feeling really bad because... the bear is after me. That's wrong. Let's run up and find that cave. That cave is not down here. We are like running back in circles. Like, see, this is really a circle. But the problem is I can't find the exact position of the cave. The cave is always on the the wrong layer. Is it on this layer? I really hope it is, because I feel like I'm getting lost at yeah, so where is the cave? We still need to go forward a bit, so it's probably not down there. Let's just go forward. Wait. The horse cannot jump that high. Somewhere around here, is it? Yes, somewhere around here. I hope it's not like downstairs somewhere. Wait, why are they still here? I thought they... Huh. Well, I definitely fought them, so... I guess they just refresh, but without the weapon. I mean, I got the weapon already, so... It's a great axe, so it's not even that good. I can never use like that heavy a weapon, so... But basically there is a cave. The only problem is that I don't know where the cave is. It's probably down there. Yeah, it's like directly below me, so it's down there. But where? Like, I'm practically at the cave, but I'm not. Oh, it's actually... Oh, it's inside this. Okay, now I understand. This is the poison part. But I thought I already went there. Yeah, I think I already... no, please. I'm probably going to die because oh, I'm going to try the lone wolves, but I'm probably going to die. Yeah. Okay. Probably shouldn't be here. Oh, okay. This is very nice. A lot easier than I thought. Well, maybe the wolves are very strong. I don't think it's I that's I am not very strong, the wolves are strong. So, okay, we got it. And did they not give anything? Just nothing? Oh. Okay. I feel a bit disappointed. Because I thought at least you could give me some weapon or something. Why is it just nothing? Like not even the... No. Oh, but there's a teacher hat. Oh, I see. This is where you meet another sorceress.
Tarnished, are we? No wonder you should turn up here. I am Selen, a sorcerer, quite plainly. Why are you here?
Yeah, I want to learn sorcery.
A yen for glintstone sorcery.
Now we have 2 teachers that we can learn the glintstone sorceries from. We just need more intelligence than 10. Our intelligence is very low.
But one must choose one's masters wisely. I was exiled from the academy.
Well, our other teacher was also exiled, so it kind of shows how people learn magic these days.
Well, you are a piece of work. Very well. You are now my protege in glintstone sorcery. But I refuse to coddle or cast kind words. Never. Anticipate grievances, young apprentice.
No, let's see what you are going to... Wait, I thought I already have glintstone pebble. Did I already learn that? I think. Let's try to get the next one, the glintstone stars. I think that's quite nice. Wow, this one requires like 23 intelligence. How are we going to get that? These 2 are both... well, I think most of these are like Dark Souls like sorcerers, so...
Young apprentice. First things first. You are a tadpole when it comes to magic. Infantile.
Well, you don't have to be so harsh on me. We're like having like 10 of 10.
To become a sorcerer, first, you must face your ignorance.
Yeah.
Now, shall we start learning?
Can probably start learning, but we don't have any souls.
You wish to continue the lesson very well. I have time aplenty.
I'm just going to
continue the lesson? Very well. I have time aplenty.
Okay, so now we have been here and oh, so many people die here. Then what are we going? We are kind of done with this. We're done with this one and we are also done with this one, I think. Or really? I'm not sure. Are we done with this one? I kind of feel like that's the case. And there's a dragon burnt ruins. The problem is, can we go to the dragon burnt ruins without being burnt by the dragon? I feel like we're going to get burnt by the dragon if we go there. This is the church we've been here. Storm Gate. Gate front ruins. Where's the gate front ruins? Have we been there? I feel like no, so let's go there. Okay. Oh, it's that direction. I see. Yeah, this is where I think we should find very early, but somehow I missed it. I don't even know how I missed that. Yes, probably need some fighting. Oh, actually no fighting. Okay, that's good. Wait, I've been here. Oh yeah, I thought I didn't have a fire, so I kind of backed out. But it's okay. I mean, we really do not have a fire. I don't think we are. Oh, okay. I see something there. And I really hope it's. Oh, it's wolf. I cannot see any others. Try saucer. Okay. I don't want to try saucer because I'm try jump attack. I mean, you have to do jump attack. Otherwise, I feel like you're just dead. Okay, let's see. It's very. Okay. It was kind of bad, but not that bad. Like, it's never good when you are fighting a bunch of them, but... Cracked pot. I think beast bones. I wish we could find some... Yeah, I see you, I see you. Okay. Glowstone and moss. Golden roll. Is that it? Oh, secret hat? What? Try gesturing. No, I don't want to. That's why I hate people who are. What? Okay, I'm like being baited all over again, but I don't know how I'm baited. I don't even know. I'm getting like baited a lot. If none of this works, then we're just going to... No, apparently none of this worked. Yeah. Yeah, and that's... Like, no wonder none of this works. It's definitely not the right direction. Like, how could that work? But yeah, this is where we can go, I think. Oh, okay, again. Why is it always death? I kind of get this feeling. Try wolf? Yeah, I'm going to try wolf. I feel like wolf is the best when it comes to like most cases. Oh, I missed that. How could I miss that? Oh, like please, what? I don't even understand, like, why is Claymore so difficult to get? I just want... I literally want one thing, and that is some weapon. It's... Like, they are not very hard to fight, but I never get what I want, I feel like. It's not a problem of like a weak foe or strong foe, it's like they never give anything that I... It's never the thing that I really need, it's just Yeah, we could return to the entrance. Okay, we're also done with this one. I just feel a little bit disappointed. Maybe not a little bit disappointed, like very disappointed. That you don't get like every kind of weapon. Okay, can we level up? Yeah, we can level up, that's good. Let's level up intelligence a bit so that we can actually use all the things that we learned. Oh wait, we can change clothes. What does that mean? Alter garments. Confessor armor, confessor hood. What? Why do we need to alter that? What kind of alteration is it? Is it like a level up thing? Oh, okay. Oh, okay, we can change it to the like the white version. But what's the difference? I don't understand for now, and I don't have any soul, so I'm not going to do it now. Okay, we went to this cave. We actually didn't went to that cave somehow. Okay. Well, if we didn't went to that cave, then it means... Oh, that death touch is a difficult one. We can still go there, and this tunnels is also a difficult one. Coastal cave we already went. Yeah, let's still go to that. I'm not sure why we missed it. I feel like we were aiming for that, but we somehow didn't go there. Okay, let's go. Wait, is it actually in this direction? Oh, okay, I see. That's it. That's literally on the other side. Which is not good, I think. Probably somebody there. Yeah, it's somewhere there. Let me go around it. I don't think it's an idea to just go from there. Okay, the cave is literally that direction. Is it like in the middle of the road? I feel like it's in the middle of the road, and it looks like. But how is it possible that it's in the middle of the road? Like in the middle of here? But there's practically nothing here. I mean, if we have to go to the middle, then we'll go. I'm just not sure which direction we're going. It's like in the dirt or in the middle of the road. Okay, this guy. Okay, now we have it, and yeah, like where is the room? Yeah, let's wait for this, guys. Oh, okay. This is not what we're going for. We're going for. Yeah, this is definitely not what we're going for. Okay, this is not good if we're fighting horse, I think. It's a lot easier if we're... Okay, we are like fighting the Knight of Brothric once again. Like, it's never good if you are... If you are like kind of fighting his shield instead of fighting this person. Yeah, we're like having a lot of fun here. This is quite easy to see. Wow, yeah, we're having a lot of fun. Yeah, I really don't want to do something that's... Yeah, let's just go. We pretty much cannot fight it. Wisdom knife. Well, I don't think there's anything ahead. Let's just go. We're not going to fight the dragon, but we want to. Well, not really we want to, we just... I don't know, let's see how far we can get. I don't think we can get very far, that's part of the problem. I was not even positive that we could get to the room. Yeah, it's pretty much straight in there. But the difficult part is how to not get the dragon know about this. Oh, okay, it's actually here. The dragon doesn't know about this. But like no one is leaving messages here. What's I supposed to? Oh, really? Is it just a treasure chest? Twin blade. Oh, I kind of know what that is. Okay, that's a very good one. That's a very good one. But I probably need to leave this place as soon as possible. Yeah, that's good. So we'll be here. We cannot go to this part yet. And we have been here. What is this? I don't know what that is. Maybe we should go there. Yeah, I'm just getting a little bit tired, and like without really knowing what to talk about, I'm kind of getting more quiet. So I know I kind of shouldn't do this, but well, I mean, there's always something to talk about. It's just I don't know. And really, like, don't get me wrong, I like this game. I just feel like it's a nice game. It's a very nice game, but it's also a very lonely game in some way. Or you're getting, well, I guess Dark Souls is always a lonely game, that you get things that's yours, but it's only yours. Is that here? It's there. We just need to continue a little bit, I think. If we go around that tree. Oh, this is a well. Oh, okay. I think I'm going to die. Well, let's go and die actually. I kinda want to play not for broadcast. I feel like it's not like not for broadcast is... Well, not for broadcast is fun. Well, let's go, let's go. feel like even ray tracing is like makes me feel like I'm connecting with something more. This is a nice game, like everything, the fighting, everything is nice, but I'm not connecting with things. Yeah. Or in general, I'm just and also I'm still thinking about the fog of love, of how I should go about it, how I should do the event, how I should debug the whole thing once like so frequently crashes. It's just very difficult. But I know this is something I want to do. I mean, it's always like that. Something worth doing is always like difficult, embarrassing, awkward, you name it. I think it's always the case. And that's the part that's nice, that it's always the case. Is there no map? I feel like there's no map. Yeah, I'm just getting some stuff. Hopefully I get some good stuff. Yeah, I think after streaming I'll probably go back, read something, and do some more Fog of Love. I think that's what I want to do. How can we equip that? Wait, is it gone? Is it just gone like that? Oh. I really didn't expect that to be like a one-time use. I thought it's like something to equip. Okay. I totally misunderstood that thing. Well, anyway, I already misunderstood that thing and it's no use now, so... Okay, I kind of see something is around there. And let's just wait. Oh, it's not that bad actually. I think I could get rid of them if I do them one by one. Well, our goal is to find the next grace, I think. Yeah, do it one by one. Do it one by one, it's totally doable. No, we can. Okay, so it's pretty much, yeah, you can do it, but it's one shot. Okay, then I guess it's not that. Let's just get the soul and then go. I mean, there's really no need to fight them at that point. Yeah, go. It's not my place yet. Yeah, I actually want to go back to the round table today and log out there.
Ah, well then.
Is there something I could learn? Yeah, I'm like always. Okay. I don't have enough money,
The
so I
golden
can't.
order shines.
Wait.
What do you need?
Who is this one?
Little time to spare. Oh, are you aggrieved at the notion you are but a visitant here? Then you would do well to remember the first words of grace given to you. Stand before the Elden Ring and become the Elden Lord. If those words held any meaning to you, follow the guidance of grace. Lay low the shard bearers and claim for yourself a great rune. Do so, and the doors to the round table's inner chamber will open.
Okay, we need to get a great rune. I just don't know what that is.
Of the two fingers. Once the wisdom of the two fingers becomes your own, I'll impart to you a proper welcome. As a true member of the round table, I have high hopes for you. I'm sick and tired of them. These namby-pamby tarnished think us no more than a shelter from the rain. We've spoken long enough. I have matters to attend to.
Okay. I mean, now we are here and there's actually not much for me to do, I think. And I think that's it for today. I mean, we had a lot of fun, and what tomorrow?